Wow. I just noticed that I have to put it way up here in order to have the students hear me. Okay, each and every one of the seats is taken, which is good. I like to accommodate at least 2/3 of the class if possible, and the rest of the students want to listen to the lecture at home, it's fine. This is what the purpose of this is, so that I could accommodate more students. Oh, let me see. Can you hear me? Let me make sure. I want to make sure that the others could hear me when they are on the system. When you want to repeat, let me see. Hello? Yeah, this is much better. I have to do this. Otherwise, they cannot hear me. Unfortunately, I don't have a string. Does anybody have anything I could tie this onto this so I don't have to hold on to this? Anybody? Let me see if I have. I don't think I brought anything with me this time. Before I had to do that. Okay. No. Okay, that's okay. I just have to hold close. Oh, you do? Fantastic. Make sure I return it to you. Thank you so much. Then I don't have to hold on to this. Thank you. Can you hear me? Hello? I don't hear my voice echo. So let me make sure this is on. Oh, why is that? Oh, I know what. I could tie it a little bit closer to me. Then I don't have to hold on to it. Hello? Hello? I'm not sure whether everybody else, but usually it should echo before. Let me see, what is this? It should be okay. Okay, I'll hold on to this. That's what I'll do. That's okay. Okay, there should be seats, right? Go ahead and take. Okay. All right, so I just want to quickly go over a few of the slides that I went over too quickly. Carotenoids are the yellow vegetables or orange vegetables. And just see whether I'm on. I don't see now. I hope everything's okay. That's the only thing. If something happens to the system, then you cannot see me, you cannot hear me, then what do I do? There are a couple of options I have. But anyway, let's not talk about these options until it happens. But anyway, I make sure the sound is good and I can see myself. That means the others can see me. All right. Carotenoids are the orange or the yellow vegetables. They're very stable. So in class, in the lab coming up next week, you'll be working with the vegetables. Whether you add acid to it or alkali to it, it's not going to make any significant changes. Okay? Now, the chlorophyll, yes, it's a very sensitive color pigment, which is the green color. I mentioned, and it is a very important vegetable for us to watch how we cook it, how do we prepare it, and how do we serve it, so that we'll get the best possible green color, vividly green color that we want on the platter or on the plate. Okay, I just want to cover, I already talked about it before. If you add acid to it, such as lemon juice or orange juice, it's going to turn it gray, very ugly color. And we don't want that. So we have to be very careful with green vegetables. We normally don't use any lemons to it, unless, last time I said, unless if it's like lemon butter on asparagus, which is okay, it's already accepted. If you have a lemon sauce served on asparagus, the asparagus is going to be olive green anyway. Okay, so in the lab, you'll use some acid. We're going to ask you to use cream of tartar to the chlorophyll to maybe broccoli or spinach, whatever we have. And you see that's going to turn to olive green, the dull gray color. And if you add alkali to it, such as baking soda, it's going to turn it to bright green, very bright green, which normally you would want a bright green color, except that it's going to destroy the texture. It's going to make the vegetable mushy, which we don't want, okay? So we have to be careful also not to add anything that's alkali. But the fact that it's going to turn it to bright green color, sometimes the chefs like to do that because they think that they're making some vegetables that are looking beautifully bright green. And however, it's a no-no to the food service directors because you're going to make the vegetables mushy. And you'll see it in the Mila lab, what we mean. Or to the dietitians, it's a no-no because it destroys the water-soluble vitamins. So we just say no. But sometimes they're pretty smart. They go under the counter, and then they just take a small pinch of baking soda, and then the food, and then we say, oh, it's okay if it's very little. It makes it a little bit better, more bright green. Sometimes it's not easy to serve green vegetables in its best possible color. Okay, and another thing we need to know is that we never want to overcook green vegetables. The reason is that if we overcook green vegetables, there is what we call organic acid that's inside the green vegetables. It's naturally occurring. That's inside the green vegetables. So if you overcook it, the pores open up, and the acid, we call it organic acid, escapes into the water and turns the water acid. And that's why if you overcook any green vegetables, you'll see that the green vegetables turn brown, ugly, gray, or brown, which we don't want. So how do we avoid this to happen? How do we avoid this overcooking the green vegetables? How do we avoid the escape of organic acid into the water to turn it brown when we cook green vegetables? One thing about organic acid is that it's volatile. It's volatile in nature. What does it mean by volatile? Does anybody know the word volatile? It is, yeah? It evaporates, which is a good thing. So when it evaporates, this is why when we cook green vegetables, try not to cover it. Don't cover it if it's at all possible. Okay. So whether you're cooking hot water or whether you are stir-frying, that's why stir-frying, you have to keep stir-frying, keep moving it. And try not to. If you were to cover, don't cover it for too long so that the organic acid doesn't escape. You understand? We don't want the acid to escape into the water. So overcooking is bad of any green vegetable, and you will see it in the lab. We'll do an experiment on that. So minimum cooking time to avoid natural organic acid escape. And what did I do? This is, all of a sudden, there. Good. Scared me. I think I moved it a little bit. Got to be really careful. All right. All right. So one thing we could do is minimum cooking time. Okay. Two, okay. Actually, when you initially cook it in water, any green vegetables, I don't know whether you notice it now, when you cook broccoli in water, what do you notice about the color of the chlorophyll, the color of the vegetables? If you cook it in hot water, what's going to happen? In boiling water, what's going to happen to the green color of broccoli, for example? It turns in color a little bit, right? It intensifies. It actually becomes more what? More beautiful. Beautifully green color is what you're initially going to find it. Why? Because it's going to remove the surface of the pores. You could actually see the chlorophyll only initially. Okay, so this green color is not going to last long. So you cook it, when you blanch it, that means you cook it in hot water, very hot water, okay. Briefly cook it in boiling water, but you must stop the cooking as soon as possible, because if you just lift it and put it on the plate, it takes too long. So how do you stop the cooking process as soon as possible? What do the chefs do in restaurants? Put ice water over immediately to stop cooking. When you stop cooking the process, then the vegetable becomes cold, and you lift it, you put it on the plate, it still looks green. And when I have guests, that's what I do, and you should do the same thing. If I have asparagus or broccoli and I have something else on top or other vegetables, whatever it is, cook it this way. Cook it in hot water, okay? And when it turns bright green, when it's ready, don't overcook. And that's what the chefs do. Okay. Chill it immediately in ice cubes and cold water. Put it through that to stop the cooking process so it's still beautifully green, bright green, and it's cold already stopped cooking. Put it on the plate. And I have it covered. And then when the guests come, about an hour later, vegetables don't go bad very easily. An hour later, it's still good. All I have to do is put it in the microwave for a little while just to warm it. It's already hot. After you warm it in the microwave, then you put whatever you need on top. I usually like to combine several vegetables for the color, contrast, and all that. Or you could cook something, anything else you're going to serve, put it on top. So this is the way to do, and actually it's a good trick to do. Cook it ahead of time, stop it with ice cold water, cover it, and then just warm it just right before service. Okay, any questions? Did I say lid off? Oh, I'm sorry. I already said that. Okay, lid off to allow that organic acid to. Okay, to escape. Flavonoids, let's talk about anthocyanin. We already talked about that, such as red cabbage. We'll do that in the lab next week. If you put it in acid, it's going to turn beautifully red. That's why if you're making a blueberry sauce, you can make it even more beautiful. The chefs do that by squeezing a little bit of lemon juice to it. Wow, it looks reddish, purple, beautiful. But if you put any alkali to it, it looks really, really ugly. It looks blue. And sometimes, if you just cook it in water, you see in the Miller lab, depends on what that water is like. Sometimes there's metal, the water goes through the metal pipes or whatever. It could turn it so ugly, you don't even want to serve, you don't even want to see it. Okay. It's very soluble water, and you see the blue color actually in the water. We'll do that also. Anthocyanin is also another flavonoid. We talked about that, and that's something like cauliflower. Cauliflower has anthocyanin no matter what you do with it. You put acid to it, you put alkali to it, does not matter. That's something you could cook ahead of time and just warm it the last minute, and then you could pretty much serve it. And then you could put other green vegetables on top on a vegetable platter, which would be very nice. Okay, so we didn't talk. Whoa, wow, what is that? What did I do? I didn't do anything. Scared me to death. I thought we were having a minor explosion. What is it? The teacher is always the last one. Scared me to death. Last one to leave. Students had to go first. What is this? Okay. All right. Did we talk about phytochemicals? I did. Phytochemicals are present in the what is that word? Cruciferous vegetables. Cruciferous vegetables are all the vegetables that have sulfur compounds. Okay. They get a little smelly at the end. If you cook it for too long, hydrogen sulfide escapes. I don't know whether you smell hydrogen sulfide before. If you smelled it before, it's very odorous, very bad smell. And this is why, how many of you smell broccoli or rutabagas or Brussels sprouts? If you overcook it, have you smelled this? Yes. And this is a smell that children don't like, and some adults don't like either. And if they're exposed to this initially, they remember it, they don't want to eat it again. So, but one thing about phytochemicals is that it's a very good vegetable. I think I already mentioned that before. Okay. They've done studies with animals in the laboratory animals, and they found that it inhibits cancer. So it's cancer prevention vegetable. And before, they thought that it's only in rat studies they found this out. And now they're recommending that all human beings should eat enough fruits and vegetables that have this particular compound. So it does prevent. As I said, they found this in animal studies, and now they're extracting this to the human studies, and they're following still with human beings to see how beneficial that vegetable should be. So you'll see it in articles, all phytochemicals, especially the cruciferous onions, okay, Brussels sprouts, rutabagas, onions, turnips there, that's a turnip there, and cauliflower, and Brussels sprouts, and what else? Those are the smelly ones. Those are the ones that are good for you. And there is another phytochemical that's also good. In addition to the cruciferous, all the fruits and vegetables that are beautiful in color, especially the fruits, such as the beautiful red berries, purple-colored berries, blueberries, strawberries, green peppers, raspberries. They are all very good. Why? It's because it has the phytochemicals that, again, that can prevent, that's what they think, cancer. And what it is they found out that these are phytochemicals are also antioxidants, because in the cancer process, it's a peroxidation. Okay, you see the radicals keep adding oxygen to it, and it keeps going on continuously, and that particular peroxidation process can possibly be stopped by phytochemicals. So now they're recommending that everybody eats all of those beautiful berries. The more beautiful they are, fruits, the better it is for you, the more phytochemicals you have in the system. Okay? And I actually covered that. The beans I'm not going to cover. In fact, we won't have time to do this. With all the kinds of beans, just soak them overnight so they get soft enough before you cook them. Actually, we'll cover this also, enzymatic browning. Whether it's bananas or apples, if you want to put them in a salad, you'll find that they will brown easily in the presence of oxygen. The reason why they brown, and then you're serving fresh fruit salad, everything looks beautiful when you're cutting them. After a while, they all turn brown, so you cannot serve them anymore. And why? Okay. The reason why they turn brown is that there's a chemical process. Okay. There are some phenolic compounds in the fruits, in these fruits, the potatoes, peaches, apples, or bananas. And they turn brown in the presence of oxygen, because there's a natural oxidase, which is the enzyme, in the presence of oxygen, okay, that acts as catalyst to speed up the process also. So I'm not going to ask you the chemical process, but I put it here so that you understand it. I probably have more information here on slides than you need, but I need to put it here so that you understand. If one day you want to look back, students have told me in the notes, you know why. People ask why. It's because of this chemical process. Okay? But they do turn brown. Okay? And how do we inhibit this browning process so it's not a nuisance? They don't turn brown on you, and you can still eat the bananas, the peaches, the apples that you put in the fresh salad. So there's several things you could do. One is denaturing them. When you denature enzyme, which is not very practical in serving fresh fruits and fresh fruits, you have to cook them. Basically, you have to kill the enzymes. The enzyme is the oxidase. Okay, so you don't want to boil them because you want to serve fresh. So you cannot
denaturing enzyme is not possible when you serve fresh fruits as such, fruit salad, for example. So, because you cannot cook them. Okay, what you do is add some lemon juice, sometimes, or orange juice. These, whether it's orange juice or lemon juice, these are antioxidants. Antioxidants, it prevents the oxidation process to occur. Sometimes it's not 100% effective, but it's good enough that you could prevent the browning to occur, okay? So that's what they do. But what's even better is that now restaurants use a special antioxidant powder. It's in a powder form. Chemically, it's antioxidant. You sprinkle that, it's even more effective. But at home, I'd rather use lemon juice. It's healthier, it tastes better, rather than use whatever they have to spray, to sprinkle on it so they don't brown. It may not be 100% effective. It's 80% effective, 90% effective. It's still good. You can still serve it, and it tastes good. Okay, but if you lower the storage temperature, if you lower the temperature in the refrigerator, it still will be okay, actually. It would help. Okay, or sometimes when you make apple pie, for example, you make the crust for the bottom of the pie, and then you start slicing fresh apples, and before long, you realize the apples start turning brown on you. So how do you prevent that? In the bowl, while you're slicing it, they start turning brown. You put some coating in it. Okay. You put the sugar in. You have to put sugar in anyway. Put some sugar in. Follow the recipe. Okay. Sugar, salt sometimes, and a little bit of cornstarch. Whatever you have in the recipe, start putting it in because it covers it and prevents the antioxidation to occur. Because it needs oxygen. When you coat it, it does not have oxygen going in. You understand? So that also would help. So blocking agents would also help. All right? So those are the ways to help enzymatic browning. Okay. Now this is a brand new slide. I probably, it's better for me to stand here, right? Than stand over there. Am I blocking? But sometimes I have notes here. Don't forget to tell students this. So I'll walk around. Okay, potatoes. I just want you to know 3 different potatoes. There are 3 different potatoes. Now, you might think that my class might be a little too elementary. Do you know that some students in the class have never had a chance to cook? And especially I found out that some international students have never even stepped into the kitchen before because it's not appropriate for them to be in the kitchen to be cooking. So I have to start from the basics. Okay? There are 3 different kinds of potatoes. Most of you probably already know. The first kind is the red potatoes. Red potatoes are red in color, round. Okay? Actually, the smaller they are, the better they are. And I'm going to bring, it's not original, see this is the first time I teach in the Mila lab after many, many, many years. So I'm going to bring 3 different kind of potatoes for my lab for you to see. The red potatoes, the green, red potatoes automatically goes green, right? So I'm sorry, take it back. Okay, the Idaho potatoes, the russet Idaho potatoes, and also the white potatoes. Those are the 3 potatoes I'm going to bring for you to see. The red potatoes, after you cook it, after you boil them, you cut it up. It's waxy. Texture is waxy. It's not powdery. Okay? It's not mealy. Okay? It's least starchy. And when you taste it, it's a little sweet. And so this is why it's great for simmering. It's great for buttered potatoes, sprinkled with parsley on top for service. And it's great for salad, potato salad. Because after you cook it, don't overcook. After they are cooked, cut them up into pieces, great for salad because they don't crumble. The texture is waxy and tastes a little sweet. It's delicious for salads or for boiled potatoes, buttered potatoes. All right. The next kind is the russet. Russet, where is it? This is the russet potato on the right, lower right. Russet potatoes. Russet potatoes. What do we use this for? They're the biggest one. They're about yay big, this big. They're blackish in color, dark brown, this. And what do we use it for? Baked potato, good. The reason why we use it for baked potato is that it's, as compared with the red potatoes, it's mealy, powdery, starchy. It's not sweet, mealy, starchy, preferred for baking, or, forgot to put it down, mashed potato. Because it's very easy. It's easy for you to break it up. Would you add mashed potato? Because once it's cooked, you just whip it together, very easy for you to break it into pieces, small, granular particles. So it's great for baked potato. After it's used, all you have to do is crunch this together. Everything softens. It's powdery, mealy. Okay? Baked potato, you eat that with steaks or prime rib. Always serves this alongside with your roast beef. It's perfect. Okay, and white potatoes is just in between. I have some samples. I'll give you some samples in my lab. White potatoes is in between these two. And it's almost more like the red potatoes depending on what size. If they're small white potatoes, they're almost the same as the red potatoes. So you could boil them, buttered potato with some parsley on, be perfect. Or you could roast. So you could try, if they're small, you could use it for salad also, potato salad also, because they're firm. All right? Versus these that are powdery. So make sure you use the right potatoes for cooking. Okay. Next. Let me see. Thought I missed a page. Okay. Did I miss a page? No? Okay. There's one on organic. Oh, what happened? There is a slide on organic. Is it? Oh, it went out of sequence? Huh? Oh, yeah. Okay, but I'm going to go according to the slide. It's possible. Okay, I'm going to do... Is that the best now? I'm going to go with the slide presentation. I don't want to confuse you. Okay, buying fruits and vegetables. When you buy fruits and vegetables, actually because they're perishable, we don't use grades very often. The grades, when we say grades, will be USDA. Grade A will be the best. Grade B will be next. Grade C will be so-so. We don't use many because the green vegetables go bad so easily. Perishables. So, but then for potatoes and carrots, sometimes they do use it because they're not as perishable. They're more stable. You know, they could last for a while. So you only see them on potatoes, carrots, and all that. Otherwise, we normally don't grade them. All right, so, but the ripeness, they grade them on ripeness, they grade them on color, the proper color, they grade them on shape. They have to be uniform and not odd shape or awkward shape, but they do grade them on size. This is something I will probably want you to remember and probably test you on it because it's easy to remember and easy for you to use in practical life. That size. The smaller are the vegetables, the more expensive they are, the better tasting they are. Would you remember that for vegetables? Buy the small ones, they're very expensive. You go to very expensive restaurants, that's all that they serve. tiny vegetables, yes. Even baby squash, but this yay big. But they taste wonderful, okay? The smaller they are, the more expensive, the more delicate, the tastier they are. But for fruits, the opposite. I'm sure I'm going to ask you this. The larger is a fruit, the sweeter they are, the more ripened they are. Got it? So when you buy for fruit, you want big ones. For vegetables, if you want to spend a lot of money, you buy tiny ones for special occasions. But they're very expensive, okay? Uniformity, of course, when you grade them, uniformity, they have to be uniform in shape and free from bruises and signs of decay. But I want you to remember seasonability. You don't want to buy watermelon when it's not in season. Watermelon is only good what season? Summer or right now. But don't buy them for Christmas because they're not going to be good. So no matter how much money you pay for watermelon during Christmas time, it's not going to be good anyway, regardless of grade. So by seasonability, consider the season. Okay, squash, you want to buy any kind of squash in when? The fall. Good, fall. So consider seasonability is what I wanted you to remember. All right? Now, this one, in my lab, I brought some basil in for them to recognize what basil is like. Whenever occasionally I will bring in some greens for you to recognize what they are. So right now, because of time, I'm not going to, I have it here. Students, do use my slides as references if you want to take a look to see, oh, what kind of greens are these? You get to see them, all right? Well, so we try to bring them in and then for you to recognize what they are. And when we make salad, we will bring a variety of different salad greens, okay? Popular herbs, same thing. Whenever I have a chance, I'll bring some herbs for you to recognize what they are, for you to smell and chop up and use in some of the dishes. Okay, same thing with mushrooms. There are all different kinds of mushrooms here. Okay, unless if you see it on the slide, it doesn't mean anything, right? If we have a chance, we will, enoki, the tiny ones, the Japanese enoki mushrooms. When you go to a Japanese restaurant, if you have, what do you have that you find them? Yeah, the kind that you cook actually in front of everybody. Yeah, they commonly use it. Sukiyaki, okay, or any of the dishes that are cooked. Button, the regular button, the American Western, okay, and portobello, larger ones, okay, oyster, okay, they fan out, pretty large also, cremini, in between the two sides, shiitake, typically the Japanese shiitake mushrooms, all different kinds. So when you go to the grocery store, you could just take a look to see what mushroom is called what, and you get to see the real ones. I don't know whether we get to use these now. We have a limited budget for the class in the lab. If we get a chance, we will show you. Okay, yes, I'm going to ask you to prepare salad greens. Okay, one thing about salad greens is that I don't know whether I'm making too much noise. Talking too loud? No, it's better that I leave it open because we've got more fresh air. Okay, if they complain, then I'll close the door. Okay. I hope they could hear. I have not been holding up to my mouth. I hope they could hear me. But anyway, in preparation of salad greens, the first thing you do, of course, to wash, to rinse. As you know, they do use fertilizer and manure and sometimes chemicals. Nowadays, always wash all vegetables if you're conscious of about that. You wash and rinse to remove the soil, excess, drain it. After you wash, it's about to be full of water. You want to drain. Please remember to drain the water. Use a spinner to drain. So you've got to drain the water. After you've drained the water, okay, make sure you remove the stem or the core. Of course. Actually, remove that, then wash is even better because you get more water into the salad greens. And this is a very important step. A lot of people don't know. Make sure you refrigerate it for about 30 minutes or so. After you've drained, it's still moist. It's still a little wet. You need some water. It's been washed. They look great. Shake off all of the excess water. Okay. Drain them using a spinner and leave them in the refrigerator. You'd be surprised. After 30 minutes, you open up the refrigerator, all of the greens stand up like a tree, almost like. They're all alive again. And this is what you want. You want to serve them when they are alive, when they look beautiful. The minute I sit down, that salad is so important to me, how it looks. When it sits in front of me, I know already whether the salad is going to taste good or not. Because does it stand up, the leaves? Did you allow it to refrigerate for 30 minutes? It does magic to it. Okay? And once they have been allowed to crisp, and they're all crisp, the leaves are all crispy, ready to eat, actually. Okay. Then you could tear them into pieces. Sometimes you have to be careful. If you use stainless steel to cut them, is still okay. If you use sometimes certain knives that have iron, sometimes it may turn in color. So that's what they say. To make sure that it's not going to turn into any other strange colors or turn brown, just tear by hand. Try not to bruise the greens. Don't tear too much, actually. They could cut it anyway. It's a beauty of the salad that it's more attractive. You know, sometimes they say you eat by what? Is it the taste first or by sight first? By sight first. You want it to look beautiful on that plate, okay? And do not bruise them. Because when it's been a long time since I taught Mila Lab. Before, when I taught it, I asked students to make salad, and they would be playing. Everything was done right. At the very end, they would be playing with it. They literally bruise the salad greens. Then it's not going to stand up. It's going to look awful. Okay, so don't touch it again once it's beautifully standing on the plate, and then you garnish with different colors. I always like to have some deep green color. Lettuce leaves are okay, crunchy, maybe tasty, but they don't look good. Combination of lettuce or just the deep. California is known for our salad greens. Alice Waters started with a variety of salad greens. We're known for a variety of all the salad greens right here that I showed you. The deep green leafy vegetables are not only just beautiful after you've allowed it to crisp. It's a color. It's a deep green. If you put something red next to a deep green color, they complement each other. Red and green are complementary colors. That means they enhance their colors. That's why at Christmas time, you wear red and green. But you normally don't want to wear red and green on you. Everybody's going to look at you, right? You don't want to be, there. Okay, learn how to fix it. On the first day, I didn't know how. Okay. So you don't want to wear red and green, but I have to allow time for sanitation safety. Okay. I could talk forever about garnishing. You do want to have those two colors there because it makes it very attractive. If you put a little bit of red, a little bit of white color, okay, maybe even a black olive, few black olives makes it even better. So think about complementary colors, colors that contrast and colors that will enhance your vision. And that's what beautiful salad is all about. Once you've done that, the other job is to make a good salad dressing. And never, never put salad dressing on the greens ahead of time. That's why in restaurants, good restaurants, always ask you, sir, excuse me, ma'am, what kind of, would you like this salad dressing? They pour it on top right before you eat. Because once you put salad dressing ahead of time, it's going to what? Yeah, it's going to wilt again. So when it's most beautiful, this is the time. After you garnish, they're all standing up looking beautiful. That's when you serve it. Or what you could do is that you could pour salad dressing in front of the guests right before you serve. Okay, don't let the greens stand in the salad dressing for too long. Otherwise, you ruin it all. They're all going to be wilted. Okay. Here are the organic. What do you know about organic fruits and vegetables and grains? Okay. Do you want organic fruits and vegetables? Yeah. What does it mean by organic? Organic fruits and vegetables mean that the crops are grown with no pesticides, which are chemicals, pesticides. The pesticides until now still worries us because we don't know what's going to do to our health. A lot of articles have written up on we don't want chemicals in our system. Nobody wants it. But if you buy organic, it's 20% to 100% more expensive. So that's a problem. So we want organic farming. We want organic fruits and vegetables. We all do. But they're expensive. However, there's some controversies now. Okay, what are organic farming anyway? What do you use? Instead of using chemicals that might be harmful to our system, what's organic? What do they use? They use cow manure, but of course it has to be pasteurized. It's organic. Pasteurized, that means killed of all germs, of course. And benign materials. Seaweeds, compost, and peat of all kinds, but pasteurized, okay, to fertilize. What are the controversies? It's, first of all, the controversy is that it's expensive. How many people want to spend that kind of money on organic farming or organic fruits and vegetables? And sometimes they say, the organic farms, yes, I have organic farms. I'm right here, okay? But then they said, well, next door to you, the other farmer uses the regular chemicals or pesticides. So if that's the case, you don't know whether the wind blows that over to you, okay? So, and also there's a big price difference. Okay? It costs a lot more than what we want to pay. Is it worth the difference? Nutritionally speaking, there's insignificant difference. Nutritionally only, that means vitamins and minerals, okay? However, the chemicals really concern us. And another controversy is that dietitians would say, yes, we're supposed to have 5 servings, fruits and vegetables, more servings. They're constantly updating that. But only about 15% of the U.S. population can meet that recommendation. That means we don't eat enough fruits and vegetables. So is it better not to eat them, or is it better to eat some that are not organic? These are the balances we have to consider. Okay? So if you have a little space in the backyard, you could always, very easy to plant lettuce, okay, basil, whatever you have. So salad greens and all that, if you like that, okay, and you don't put chemicals in it, that'd be great. Any questions? I wanted to talk about that. I just added that slide in, okay? Genetically modified food. I don't know why. Okay, now we're allowing GMO products. What's GMO? GMO is genetically modified food. It's a process that they introduce to plants and edibles. It's a process to achieve a desired gene to occur over and over again so that the survival rates are better. That means they could combat diseases. And I saw just last week's chemical engineering. Look what GMO food could do for you. Here's a corn plant, that's not GMO. Here's a plant. I don't know whether any of you saw this. My husband is a chemist, so that's how I know. Okay, so he gets a chemical engineering. And another photo of corn plant that's beautiful, growing with a lot of corn and all that. So what they're saying is that with with the growing population in the world, do you want to feed them or do you not want to feed them? If you want to feed them, the GMO is a solution. So FDA has approved a lot of GMO foods already. And of course, you could see, it's labeled, but whatever it is, the FDA has approved them. But sometimes not only that, they genetically changed. They often would spray with chemicals. And these harsh chemicals is what we don't want either. Because in order to get the genes you want, initially they have to spray with the chemicals to remove everything else, but have what they want for growth. So what they're most interested in is growth. And FDA has approved what? They have approved soybeans, potatoes, canola. Even recently, which I don't like, I love apples and salmon. Now, I could taste whether they've sprayed with chemicals. Apples taste so bad. I have a very sensitive taste. I don't know whether all of you do or not. I could taste whether it has chemicals in it or not. And my husband couldn't taste it. Maybe somebody else couldn't taste it either. I would reject it because it leaves that a little bit bitterness on my tongue, and I don't like it. And some people could taste actually salmon that's raised. We'll be talking about that when we talk about poultry and fish that's raised in lakes or farms, local farms for fish. But the difference between, to me, ocean fish and farm fish, to me, is a big difference. But not everybody could taste the difference. So they just eat them. Okay. The fact that they often are sprayed with harsh chemicals is what I don't like. And the fact that if FDA approves them, basically, we get them everywhere. So often, whatever crops that they approve, soybeans or potato, whatever it is, these products are made into other processed foods, which I don't like. You understand? The basic ingredients are GMO, and then they make them into processed cake mix, whatever it is, we don't even know. And USA does not require GMO labeling. I know there are several groups of consumers who are raising a lot of issues about this, and they want the government to do something about it. So let's follow up to see what's going to happen next, okay? But they do look wonderful. The crops do look beautifully. They plump, they're huge, and they look great. So we would know the difference. Now, I'm not going to talk about this very much because they're cooking. We already talked a little about cooking. The rest, as we cook other, because I'm limiting with time, we will, in lab, we will demonstrate all of these cooking methods, moist heat and dry heat cooking. So we'll talk about that as we do the Mila lab. Okay. Preparation of vegetables. We do want to cook the vegetables so they're more palatable. We want the texture to be a little softer, flavor to be improved, odor. We want to remove any sulfur-containing vegetable, or not remove, but prevent sulfur-containing compounds to be given off. So there are a lot of ways we could do to get the best out of this for the final product. And of course, color to be not just retained, maybe even enhanced. Nutrient retention, of course, to be maximized. So as we cook vegetables, we have to take all of these into consideration. I don't know how much time we have in Mila Lab, but we will see what's going to happen with the ones that we're going to be working with next week. Now, I just want to briefly touch upon canned vegetables and frozen vegetables. With canned vegetables, do you know how they can vegetables? Do you eat canned vegetables? Okay. Some of the canned vegetables are okay. Okay. Corn looks okay, tastes all right. Okay. Carrots, perfectly okay. Some of the institutions use them. You wouldn't even know. Of course, the texture has changed. Okay. But for green vegetables, like peas and green beans, what happens with canned greens or canned peas? They're green vegetables. what's going to happen? They all turn color. Why do they turn color? The principles we have talked about is happening here. What's canning? Canning is a two-step process, it says here. Whether it's raw or cooked or packed into the container and sealed, okay? And then they get cooked. When they get cooked in those cans, for example, the green peas packed in there and cooked, remember we said the volatile acids have to escape from the green vegetables? Otherwise, the volatile acids or the organic acids are going to turn themselves to the olive green color. And this is what happens. That's why canned green vegetables, peas or green beans, to me, unless we make it into salad, it's just not edible. First, it looks bad, and texture is bad. Because, as I said, it's an enclosed environment. Okay, just like we put a lid on. The volatile acid does not escape. So the acid is retained inside. The acid turns them to brown. Okay, so basically we don't use them, but they're great for shipping to other countries, to the army, anybody who could keep them on the shelf. They last for a year or so, or even more. Okay, but mainly because the canned vegetables are heated for so long that to destroy, yeah, they could be kept for that long because all the microorganisms are all gone, bacteria are all gone. You could keep them for a long time. That's the advantage, okay? Other than that, because they've been cooked so long, people often just serve just like that. You open up, just eat it because it's been cooked to death, basically. And it's because it's a sterilization process. There are no more microorganisms, and that's it. Advantages, heating destroys, I already talked about. Retards decomposition, lasts for a year or more. Long storage, if you want to ship them to other countries to save people from starvation, this is great. Okay, frozen vegetable, a little bit about frozen vegetable. Frozen vegetables, if you were to freeze vegetables, I've talked to a lot of people, they said, oh, you've got so much of the berries, you've got so much of the vegetable, why don't you freeze them? You think that just by packing them in those plastic bags, putting them in the freezer, would that work? Depends. It depends. Mainly because if it's raw vegetables, they must be blanched. Okay, blanch means cook them in hot water. Blanch destroys the enzymes, kills the enzymes that are living, that cause undesirable browning deterioration. So you don't want to freeze anything. But once it's cooked, if you have some leftover vegetables, you're going to be gone for a week or 2 weeks or even a month. You don't want to waste them. You don't want to throw them away. Cook them, blanch them, cook them in hot water, and then put them in the bags and put them in the freezer. Fine. Okay, but just don't freeze them without cooking them because these enzymes are still alive and acting. Okay. Now, how about fruits? You cannot do it to fruits. And that's something that the food scientists have been working on for a long, long time. How do you freeze fruits? It's very difficult. Okay. And but they have thought about different, I don't want to talk about it, the very, very low, extremely low temperature. The lower is the temperature, minus 60, minus 100 degrees, the better it is. It does not destroy it as easily. So there are methodologies they're working on. They're okay, but the texture still changes. Still not the same as fresh fruit. Okay, so you may not want to do it because if you want to do it, okay, you can, okay, but sub-zero temperature will be better than regular freezing. Okay, so I already talked about all of this. How should the following vegetables be prepared? That's just review questions. Why is it that these are good? We already know. I have to move on with this. Oh, in the lab next week, I just want to tell you, as a group, we'll have broccoli. I think I've requested broccoli to study the chlorophyll, and we'll use acid, which is cream. We're going to ask you to use cream of tartar to see what the acid effect is on broccoli. And we're going to use baking soda on the effective alkaline on broccoli. And we're going to do some blanching. We're going to, and then we'll talk about the organic acid, cover or not cover, to see what happens. And then red cabbage, which is the anthocyanin, we're going to ask you to put some acid to it, alkali to it. We're going to have you see what the color changes are and what's going to happen when you blanch. And then carrots and cauliflower, no effect very much at all. We want you to see it. That will be done in the Miller lab. Okay, and we'll have apple, an experiment on apples, enzymatic browning, the control, some lemon juice, saline, some sugar solution. Put them in. Depends on whether you're going to submerge it completely or not. If you submerge it, it's going to turn out okay. Potatoes, as I said, I already talked about the 3 different potatoes for you to see the effect. Let me see. Yeah. And that's it. Okay. So I have to move on with the next topic. I only have 1 hour to finish, so I will move on. Where did it go? If you find it, let me know. Sanitation, oh no, I don't want the PDF file. At the bottom? Huh? Oh, above the PDF. Ah, here, thank you. Okay, sanitation safety. Okay, so we're going to be talking about foodborne illnesses for the next hour. I don't know whether you knew this or not. 1/3 of the reported diarrhea cases that's reported seem to be linked to foodborne illnesses. Sometimes we didn't know that we ate something wrong. We thought that we just have the stomach flu for a day or so, and we move on. If you're healthy, we'll move on. If you're not healthy, you may get sicker still. But sometimes we don't know, but sometimes we do know. But when it's more serious, if you've eaten a lot of it, it affects you more badly, then you have more severe symptoms such as gastroenteritis, nausea, abdominal cramps, diarrhea, and vomiting. Okay? And very severe cases actually may result in hospitalization. As I said, many of the cases that actually go on, people didn't know it was foodborne illness, and you move on, you get well, you're healthy, you could conquer it. Okay. Now, foodborne hazards, there are actually 3 different aspects. We're only going to be talking about biological. I'm not going to be talking about physical. Physical, there are 3 aspects. Physical basically refers to maybe a broken glass that has gone into the food, or some metal shavings of some type from the equipment probably went in there. So I'm not going to talk about that. Chemical, I'm not going to talk about chemical either because it doesn't belong in this course. Maybe cleansing agent got in there, maybe some bleach got into the food and made us sick or whatever. So I won't talk about. So we are only covering, I just want to tell you that this is the only aspect that we're going to be talking, and it's going to take at least an hour for us to cover. So, so we're going to be talking about just this: biological, bacteria, viruses, molds, parasites. I'm not even going to be talking about prions, which is the mad cow disease, because it's rare. Okay, I could. All right. So let's talk about bacteria first. 90% of the foodborne illnesses are caused by bacteria. This is why I want to spend more time on it. 90%. That means almost all of the foodborne illnesses caused by bacteria. And they have all different shapes, all different as you can see, they classify by the shape, cockside, or spherical. Round ones, okay. Such as sometimes you see the name being, the end name being Staphylococcus, Diplococcus, Staphylococcus. Coccus means round. Bacilli will be the rod shape, long rod shape, such as this. So the word would end with bacillus something. Bacillus something means they're rod shape. Spirilla are these spiral. So sometimes when you see the name of the bacteria, you pretty much could figure out what the shape is like. Okay? Motility, some of them have flagellae. They could actually swim. They move around from one part of the liquid to the other part. They could, if you take a look, let's see. Here they are. They have wings, flagella wings that they could swim, they could move around. Okay, endospores. I just have to, because it's in between class time. I'm going to open again later because they're all talking. Distracts me, that's why. Endospores, they're spore forming. Sometimes they have a hard crust around them. When it happens, that means they protect it with this crust. Okay, so they're more resistant to heat. You have to heat it for a couple of hours, a boiling before anything happens to them or something like that. So spore forming, they have this coating that actually protects them. So this tough coating could be difficult to destroy. Now, this word I want you to know, but of course you probably already know, when we say pathogens, we're more particularly interested in the pathogens. Pathogens means disease-causing. Some of the bacteria, by the way, bacterium is one singular word. That means only one bacterium. More than one is bacteria, okay? Okay, pathogen means these bacteria that are disease-causing. Hello, I hope I'm still on, yeah. It seems a little soft. Okay, otherwise I'm in trouble with the rest of the students because it doesn't echo. You could hear? Can you hear the echo at the back?
No, I feel like
it's on. Okay, good. That's great. Okay. Pathogens are disease-causing. Okay, so those are the ones we want to study and know a little bit more about. Bacteria grow very quickly. You may start with one. And then from 1 turns into 2, they multiply, 2 turns into 4, 4 to 8, 8 to 16, 16 to 32, and they multiply very quickly to the billions in 10 hours, and then finally they reach this plateau. The plateau is a stationary phase. They no longer grow when they reach that billions in numbers. Why is it they don't grow? Why is it that they reach that stationary phase and they do not grow anymore? Can you guess? No space to grow. Good, because they get overcrowded. What else? Because they die. They die from their own waste often. They cannot, for survival reasons and for other detrimental effects from overcrowding, okay, they die. So this is why we reach a plateau there. Okay. Now this is a plateau that's reached, but in healthy people, doesn't matter. Okay. We could survive, and eventually it's going to decline. Now, if you're healthy, if you're young, you can fight it, you get well. However, if somebody is sick, elderly, or young, very young, infants, they may not survive through. So it all depends how healthy you are, but still, if it's very bad, you still have to go to the hospital and the doctor to get treatment. Okay. Now, what do the bacteria need for growth? Okay, generally speaking, the bacteria need whatever human beings like. Whatever you like, bacteria also like. Food, they like neutral food. They like especially food that are neutral, such as meats, milk and egg products, combination, whatever you like. Okay, fish, chicken, especially cream products, neutral, they love it. Okay, they fight with us for food, for what we like to eat. And next is, the reason why I put it in this is because sometimes referred to as fat Tom. If you forget fat, Tom. Okay, so A for acid. They like neutral to slightly acid food only. So that's what we like. We don't like anything that's too acid. So any of the neutral food, especially milk and egg combination products, they just love. Chicken, meat. So they fight with us for food. Temperature. They like food that's at room temperature. They don't like anything that's too cold. They get destroyed. Or if that's all, we keep them in the refrigerator to prevent them from growing. Or the temperature that's too hot. Of course, they get burned. They die from boiling. Time. They need time for growth. Did you see? 2 to 4, 6, all that takes time. They need time for growth. This is why any of the perishable foods should not be left at room temperature for too long. And later on, we'll talk about what amount of time you can leave at room temperature. Time. So to prevent them from growing with the prolonged time, put them in the refrigerator where they don't like. Okay? Oxygen. Some like oxygen, some don't. And we'll talk about some that like oxygen. And those with the hard coating, okay, spore formers, okay, they could grow without oxygen, and that's troublesome. Moisture. We like moist food, right? They like moist food also. That's why they don't like dry food. Let's see. So let me, I forgot to elaborate on some of this. I wanted to make sure. We talked about body temperature, time. They need time for growth, oxygen. Okay. Moisture. Okay, let me illustrate this one. Okay. They like moist food. To prevent them from growing on food that we like, how do you remove moisture? In the olden days, okay, salt, you could dry, okay, salt, okay. Coming up, salt is actually under osmotic pressure also. Salt, yeah. You could dry meats. Can you dry meats? Yeah. What do you like that you could buy from Costco now? Yeah, jerky. Yeah. Any of the dried meats. Now, as long as there's no moisture, they keep it at room. You could keep at room temperature for a long time. They won't fight with you. They won't eat them because there's no moisture. So this is why they're making all kinds of dried meats you could carry with you when you travel or on the plane or what. Okay, moisture. Okay, and inhibitors, osmotic pressure. They don't like anything that has too much salt or too much sugar. Let's say too much sugar on jam. Bacteria doesn't grow in jam. Later on we'll talk about molds will grow in jam because it's too sweet. Okay. What else? That has high osmotic pressure. Anything that's high in salt also. Somebody talked about, in the olden days, they had no refrigeration. So how did they keep their meats after they killed the animals? How did they preserve the meat? In the olden days, salt. They salt them, and then they hang them to dry, and also salt them. They'll last for a long time without refrigeration. So they don't like it. And what else? Oh, chemicals, of course. That's why we kill them with antiseptics, not completely with antiseptic, disinfectants, okay, and sanitizing agent will be more effective. We'll talk about that. Oh, No, okay. Okay. Last time it took me so long because I didn't know how to turn it back on. All right, so the time temperature control. We talked about foods that require time temperature, protein food we already talked about. They like any of the protein food that we like, meats, fish, dairy. They like cooked food, especially cooked food, that's left at room temperature. And that's why you don't want to leave any of the cooked food in room temperature. One time we went to Italy, I tell you, everything looked so good. I got something. I thought it was pizza. And I thought usually here they don't leave pizza out for too long. Once it's served, they serve it. But evidently the pizza was in Florence, Italy. I tell you, I got so sick. It had to be the pizza that I ate. Because I didn't know how long you have to be careful when you go to another country. I didn't know how long they left at room temperature. I was so sick, I couldn't go to the next city. So cooked food, you have to be very careful, whatever that's cooked. Okay. If you just finish cooking, you serve like Costco, it's okay, very fast. It's cooked, it's okay. But if you leave it at room temperature for too long, that's when you get sick. Because the bacteria fight for the food. They love it too. They fight with anything that you like. They fight with you for food. Ready to eat, anything, pizza, or cream puffs. They love cream puffs. Anything. Cream puffs, especially milk and eggs. Oh, they love it, just like the way you do. We do. So we never keep them at room temperature. Always refrigerate it. Anything that's cut up fruit, because there's no more exposure for the bacteria to attack. Now, before we weren't so concerned. Now we found out that a lot of fresh sprouts and the untreated garlic have been contaminated in the field, and they could germinate. That's why fresh sprouts, when you go to, sometimes we'll go to Vietnamese food, a restaurant, they serve you raw sprouts, bean sprouts. And I usually tell them, can you cook them? They would do that. Because now they're more conscious now about this, because this has happened a lot. Okay, so especially sprouts that are raw, okay, because our broth in the soup, the noodle soup, is not hot enough to destroy it. Okay, so this is a new concern now. Okay, now let's talk about the bacteria. Let me see how much time I have. Okay. We're going to talk about food infection, food intoxication, and food intoxication. Food infection, I'm going to, typically salmonella, I'm going to have to be a little quick because I like to finish this topic. I'm a little behind. Okay. Food intoxication, staphylococcus, or Clostridium botulism, and food intoxication, typical example is E. coli. So I'm going to go to the next slide to explain more in detail. Now, I've picked out the foodborne illnesses that are very common in this country and very common to everybody. Actually, all human beings, we have to be very careful. But there are always new ones that are coming out. We also have to be careful. I could only teach certain number of them, and then the rest, we just, once you have the basic information, you could catch on very easily if you received it in the news or whatever. Let's talk about infection first. Okay. Typically, the reason we'll call it infection is that 80% of food poisoning actually came from food infection. So I'm going to talk about that. And of that, the most common one is right here, salmonella. Okay, I'm going to spend more time talking about that. Okay, it's basically food infections is when we actually ingest or take in the bacteria into our system, and they start to grow in our intestine and make us sick. So they take a little longer incubation time before they give us problems. Food intoxication or food poisoning, okay, is when the bacteria grow on the food and they release toxins. And it's these toxins that cause us or cause illness, anus. So these food, okay, that can, these food that we eat could be laden, could be full of the toxins from the bacteria. When we eat them, it's the toxins that make us sick. Staphylococcus, okay, is an example. When it's food intoxication, there's no change in appearance, no odor, no flavor difference either. So we don't even know until we get violently ill. Food intoxication is when the bacteria enters the intestinal tract, and then they produce toxins when they're in our intestine. So the toxins produced inside our intestine. And the example here is E. coli. So I'm going to explain this more in detail anyway. Let's talk about salmonella, which is very common. How many of you have heard of salmonella? Most of you have. Now we're going to talk about salmonella. So where does it occur? Yeah, eggs. More commonly would be poultry and eggs. Okay, food, raw. Let's talk about the eggs first. The raw eggs, more particularly with raw eggs. Anytime you buy eggs, any eggs that are cracked or broken, you don't want them. You can return them. They're supposed to give you eggs that are not broken. Okay, mainly because we're all so afraid of salmonella, so prevalent. So sometimes, so the only way to one thing very good, one thing we're lucky about is that salmonella gets destroyed easily with heat. Once we cook them, they're dead. So anything that's raw is what we have to be cautious about. Okay, so any food with raw eggs. What kind of food has raw eggs? Many, many years ago, during holiday time, we used to have eggnog. We no longer have eggnog that's made with raw eggs anymore. Now, they pasteurize them. They don't taste the same, but it's okay because of salmonella. Anything made with raw eggs. And before, mayonnaise used to be, of course, made with egg yolk, and we'll be doing mayonnaise in class. But of course, we'll be using mayonnaise, we'll be using eggs that are not broken, okay? And we're all healthy, and I think it's pretty safe to do that because it's demonstration later on of permanent emulsion, okay? But anything, now when you buy mayonnaise, it's all pasteurized because they don't want to take any chances, okay? So, any of the dairy products, anything, okay? And then also other meats and fish and also has salmonella, but most common place would actually be the eggs and from the chicken, from poultry. They said that, I saw a television program, they showed all of these chickens crammed into those cages, and they're not allowed to run around these chickens. It's terrible just to see them. And they said that when you see that, it's about salmonella. If one has salmonella, then basically all of them will have, just from one to another. You have salmonella going from one chicken to another because they all crowded together in those cages, and there's nowhere to go. So whenever we buy chicken raw, we have to assume that chicken is filled with salmonella. So we have to take every precaution and not to ingest it. The chopping board has to be a separate chopping board. Okay. Afterwards, you have to sanitize it. And your hands, make sure you wash and sanitize it. So in every single aspect, we have to be very cautious. So any unpasteurized egg products, surface of meat, surface of chicken, surface, and even in the cavity, the chicken eggs came from the cavity. It's just filled with salmonella, that's what they say. So contamination, from humans, sometimes we touch them. After we touch them, wash our hands really well, sanitize. The chopping board has to be really scrubbed, and use a sanitizing agent or Clorox, diluted Clorox to sanitize. So whenever we cook before, it was not such a prevalent problem, but now we say, well, even when we cook turkey later, or we talk about cooking turkey and chicken, everything has to be cooked. Cooked through is what it is. If you see any faint red color of a little bit of the blood, you basically don't, people are just very worried. But in reality, 160 degrees will destroy it, is what it is. So if you cook it, there's basically no problem. Okay? So inadequate cooking and reheating is a problem. And actually, let me see. I just want to know this. Does this work? Could I point it? No, it doesn't point. So, sorry. Something's wrong with this, so I have to go back. I was hoping that I have a shortcut, so I go a little quicker. Okay, salmonella. So I don't. So raw eggs, we've got to be careful. Cracked eggs, we don't accept. Okay. No stuffing in large birds. Why is that? No stuffing in large birds, such as turkey. We don't want to stuff. You don't get. We don't dare stuff turkey now. The turkey has to be separate. Okay. It's because when we bake or roast chicken or turkey, the temperature goes from outside in, often may not reach the middle part of stuffing, and this is where the problem arose a while ago. So we said no stuffing. So stuffing, especially institutions, hospitals, absolutely no. And bake it in a separate pan. I don't stuff turkey either. Nobody does. Okay. Roast chicken, sometimes if they could heat all the way through, it's different with stuffing, but we don't do that either. Okay? Because it's such a prevalent problem. No stuffing in large birds. Okay? And anything that we reheat that's poultry has to be reheated to 165. Okay? And we have to remember cold food will be served cold and hot food to be served hot. Nothing at room temperature is what are we talking about. So poultry is particularly vulnerable. We treat all raw turkey, raw birds, raw chicken very, very carefully now. Okay. Especially cross-contamination. Anytime I buy raw chicken, I use a separate chopping board, plastic chopping board, not wooden, because if it's wooden, it gets caked into the wood. Plastic ones. Okay. I do all the cutting there. After it's done, wash your hands, wash the chopping board. Otherwise, it's cross-contamination. If my hand still has some of the salmonella, and I go to salad greens, and I work with salad greens, and salad does not get cooked, and so we get sick. This is what avoid cross-contamination. Separate the raw and the cooked and wash hands, especially any food that does not get cooked again, such as salads. Dangerous, right? Okay. Anything else that we miss? Okay. Symptoms. Okay. Diarrhea, pain, abdominal pain, chills. You cannot tell from one food poisoning to another because they pretty much have the same vomiting, dehydration, pretty much the same symptoms. So this is the one I would like you to remember, salmonella. I put down two more, Shigella, infection, and Listeria. I'm not going to test you on it, but you hear this in the news a lot. So they all fall in this group, bacterial food infection, but it's just that there seem to be more and more. We've got to be careful. But I listed them, so in case you look at my notes, there are a couple more that we've had some episodes of Shigella and also Listeria. Now let's talk about Staphylococcus. Staphylococcus is food intoxication. Food intoxication is not the ingestion of the bacteria. Okay. What it is, it's the toxins that are produced by Staphylococcus aureus. It's the toxins that make us sick. Okay. So the incubation time is very short. Only half an hour to 8 hours we'll get sick. Now, what do they like? What kind of food do they like? Salmonella, they love poultry, right? With Staphylococcus, they love milk and egg products, especially milk and cream fillings. But they also attack meats, ham, poultry products also. But they especially like cream puffs, creamed dessert, and all that. And where do we get Staphylococcus? Okay. Actually, it's from Staphylococcus, we get them from our human skin. Human skin, and also our nose. When we blow our nose, our throat, especially when we have infection. What else? Wounds, infected pimples, and boils. So anybody who has some wounds of some kind, stay away. If you have a cold, if you have flu, please don't come to the if you don't work in the visitor rooms. If you work in the visitor room, don't go to the visitor room to serve guests. Don't come to the Mila lab, okay? Because you just give it to the other students. And I already mentioned in my lab today that all you have to do is to tell us, and we reschedule you for another lab if you're sick. Okay. And let's see, how does it get transmitted? So anybody who has a wound of some type, open wounds. I remember I was having dinner with a food inspector. And we were having dinner, and he said, Janet, I just closed a restaurant. I said, what do you mean? He said, I just closed it. They can no longer run the business. I said, oh, what happened? He said, I went into the kitchen of that particular restaurant. I saw a food service worker with a large wound on one of his fingers. And he said the wound was going through the bandages. I saw it, and there was no covering. That person should have never been able to work, should have never been allowed to work. So you know what he did? He closed the restaurant and chased everybody out, and they not to come in. They got cited for I don't know how many points, whatever it is. So the owners were not allowed to reopen until they show signs of improvement, how they're going to prevent this in the future. Any wound of some type. So if we blow our nose in the kitchen, we're supposed to go to the sink, wash our hands, okay? Go to the washroom, wash whatever the part that you have some problems or issues with pus, okay? Because you don't want this to go back to the food, okay? So they easily transmit it when you sneeze, cough, or hand contact because you blow your nose. And that's why wash your hands, sanitize before you even start working. Okay. Favorable, once they get transmitted, they have to have favorable food. Their favorable food will be what? Dairy products. So if you go and fill the cream in the cream puffs or whatever it is, and use a finger to dip and put it in your mouth, it's even worse, right? And so the food has to get some of this Staphylococcus, and then with a favorable temperature, room temperature and time, if you leave it at room temperature for a few hours, wow, you're going to infect a lot of people, getting them sick. So caution, workers with any infection, with any wounds, any pus pockets of any type, sick workers have to stay home. And if inspectors coming, anybody's blowing the nose and really looks sick, they'll be chased out, as I said. If it's very bad, like the situation I talked about, they'll close the restaurant. Okay. Refrigeration. Any food cold has to be refrigerated. Okay. Any refrigeration has to be cold, refrigerated to keep cold. Wash your hands. They tell you, actually, you have to pass food sanitation tests before you work, all the food service workers. And they tell you exactly how long, how to wash hands and all that. Soap and water. 20 seconds, personal hygiene and use gloves each time you serve ready prepared food. Use your gloves, not your fingers. Most important, sick workers have to stay home. So it's toxins. It's the toxins that make us get sick, okay? I have 10 more minutes, right? Let's see how much I covered. So the third category I talked about, I have an example here, is that I'd like you to know. As I said, anything dotted below is only for your notes. If you want to look back, I'm not going to test you on Clostridium perfringens, but it is in the same category is what I'm saying. Okay, I'm going to be asking you to remember Clostridium botulism. The reason why I want to tell you briefly about this is it's so deadly, fatal. People who get sick with it often die. Okay? Because they have very poisonous toxins, and they are rare, but they're anaerobic. They don't need oxygen. You know what anaerobic is? Anaerobic means no oxygen. They don't need oxygen. Aerobic, what is aerobic? Need oxygen, good. They don't need oxygen, so often they occur in canned food. Spore-forming gas, they form the spore to protect themselves. So they could go through pretty high heat without getting killed. Spore-forming. And they have gas, they're gas-forming. So if you open a can, usually they're living inside the can. If you open a can of food and you see gas and it smell, okay, foul smelling, throw them out. I have experienced this. It was some kind of a canned something. I forgot what it was. I opened it. It just smelled so badly. And then you see anything that's swollen can, don't use it. Return it. Spoiled, exactly. And not only that, gas forming. You see the gas. Okay, smelling you don't. And throw it away. Okay, it's usually from inadequate canned and processed foods. United States does a really good job in canning, and they get examined, inspected with no issues. But it's only when you get canned food from other countries, which that particular can came from, you have to be careful. If you smell anything, throw it away. Okay, where do they come from? They don't need oxygens. That's why they grow inside the can. They come from the dirt or soil-grown foods. So it has occurred in this country, in the United States, okay, with green beans, with cream of mushroom soup, canned cream of mushroom soup, neutral food, green beans, and green peas, I think. Okay, this foul odor of milky color, I actually saw this myself. Did I throw it away fast? So be very, very cautious. And no home canned food, because you cannot bring that temperature up so high. And we've had a case of actually tuna fish also, because it was that, you see, they get destroyed. Even though it's anaerobic and all that, it's very difficult to kill them. But if you cook them to death, cook them at high temperature for a long time, they get killed. And this is why, I mean, take a look at a can of tuna fish now. You see a rim of overburn rim, you see. That means the can was heated at extra high temperature to have this burning occur. They now know they have to heat it excessively well to destroy botulism. We don't want to take any chances, especially neutral food, canned peas, canned beans, and all that. So no home canned food. Okay? And for those who are dietitians who are going to be working in the hospital, and if your patient tells you, my daughter is bringing me some canned green beans today, so green beans, neutral food, not acid, okay? Oh, I'm going to be having, or may I have that? Absolutely, no, no, no. When they're in the hospital, they have to eat hospital food. If not, they have to be, turn them in, they have to be examined what it is. And the dietitian will be able to determine whether they could have it or not. Because the hospital is responsible for the patients. Okay, home canned neutral food, I myself would not attempt to do that. No sense doing it. I get better green beans canned anyway. But I would only can fruits, I make a lot of preserves. It's acidy from plum. I have a plum tree and that. But I know what to can and what not to do. But neutral food, don't ever do that. The symptoms are very devastating. Look, dizziness, digestive upset. Okay, double vision, difficult speech, and death. Before, they couldn't even rescue. Those who were sick, they couldn't even rescue them. Now, they have an antitoxin developed, which has helped with reducing death. Before, patients just died. Okay. Clostridium perfringens, I put it there in the same category from dirt and all that, spore forming, but I'm not going to talk about it. I won't test you on it. Okay, E. coli. Got another 5 minutes, maybe I could do that. E. coli. E. coli, what is it found in? It's bacteria food intoxication. Okay. The bacteria would have to go inside the animals and then inside the intestinal tract. Then they form the toxins. E. coli is very common, naturally found in, actually, it's naturally found in human or animal intestinal tract. Okay. It causes problem when fecal matters get into the food supply. And this is why if you're a food service worker, there's always a sign in the washroom, in the toilet saying, food service workers must wash hands the proper way. How long? 20 seconds. They all know. They've been trained to do that. And then sanitize before they could return. If after they've been to the washroom, bathroom, they must take caution, because fecal matters could get onto the food and water supplies, what it is. And what kind of food? Contaminated carcass meat, raw or cooked or uncooked beef, unpasteurized milk, apple juice, fresh fruits. One lucky thing about that, we've had a lot of E. coli incidents. More recently, spinach and all that. Okay, if you cook it to 160 with most of these, if you cook it to 160, it destroys it all. So with salads, that's why that spinach episode, that time with Chef Dan, I told Chef Dan, no more raw, no spinach. He said, well, I could, if I have spinach, cooked spinach on the menu. I said, no, let's just forget all, no spinach when we had that bad episode. So, but we've had incidents with Taco Bell having problems because ground meats were not cooked to the proper temperature. 160 degrees destroys all. Basically, if you cook it to that temperature, you basically destroy all of the microorganisms. And wash hands for at least 20 seconds, and especially with children who went to Taco Bell to eat, and a couple other incidents in the past, it would cause hemorrhagic diarrhea, and they die from that. Let me see how much more I could cover. Now I've covered all of the bacteria. As I said, I've had these I'm not going to test you on. I put it there because they're in the same category. I only picked out one important one for you to know. Okay? And then now, let me see what time it is now. Now it's only, I've covered bacteria, it's only molds, viruses, parasites. I'm not going to talk about prions, actually. Okay? Molds. Is it safe to eat bread? You know, where do we find molds, by the way? On what? Maybe sometimes in jam, if it's left at room temperature. Sometimes on fruit, a lot on fruit. They like the sweets. On bread and all that. Can you eat the rest of it if you remove the mold? Always remove the mold. We used to tell them it was okay once they remove the jam that has the mold, the rest is okay. But now it depends on how much of the jam is affected. Okay, and also depends on what kind of mold, because there's certain molds that are carcinogenic. Let me see. Oh, I did not, I'm sorry, did not go to mold. There's certain molds that are carcinogenic. That means it's cancer causing. And more specifically, often from peanuts and grains. And also, you know, some of the Asians, especially Japanese and Chinese, like the soybean a lot. Not moldy, they're the fermented soybeans in cubes, and they use it to cook vegetables and all, eat it with congee and all that. And they found out that why is that they have cancer so often from these. And so some of these are carcinogenic, that means cancer causing. So now all the Asians, they said that you don't even find this fermented curds, bean curds anymore. Nobody buys them anymore because this is what they found out. Okay, from some of the curds. Now viruses, let me just finish it. Viruses, okay, there's certain viruses that occur with seafood. Okay, now I'm talking about hepatitis A that can occur. Hepatitis A, food could be contaminated with the fecal matter from polluted shellfish, most, you know, like clams, from waterbed that's not clean. This is why we often, I want to make sure I'm still on. This is why the waterbed is very important. Make sure that good restaurants will buy them from the water source that has that tag, certified and inspected waterbed. Okay? Because sometimes if they are from contaminated water, okay, we have to be very cautious, especially shellfish. And this is another reason, okay, that when you eat sushi, you also have to be very, very careful. Make sure you go to a good restaurant, reputable restaurant. You don't go to a restaurant that gets fish from any source. They should come from proper sources. And parasites, trichinosis, associated with pork only. That's why we eat pork that's done. We don't eat raw or semi-raw pork, mainly because trichinosis has parasites. Okay, and now we're parasizing raw seafood also. So sometimes, yes, there are people who can get sick from seafood that's raw. My own brother got really sick, okay, from what? Hepatitis A. So you got to be careful depending on where you go and also which country you eat it from. And I think I would have to, I'm sorry, yeah, I cannot hold you anymore because this is closing. Okay, I'm sure. Thank you for your patience and for your attention. I'll finish up next time. Oh, wait a minute. It's a class until, yeah, it's, what is it, 10 of? Is that correct? Can you check? Huh? 4 o'clock? Yeah. Is the class until 4 o'clock? Can you check? Good. I need to finish it up, if you don't mind. I need to hold you. If you want to leave, you can leave. But at least I want to finish up for the rest of the class. Okay? So we talked about viruses, hepatitis A. We talked about parasites. Trichinosis has to do with pork. And sometimes parasites are present in raw seafood also. Okay? Thank you for those who want to stay. Now, I just want you to know what this word is, HACCP, okay? Because we've had so many incidences of food poisoning, they've come up with a system in every food manufacturing company or food production or food service establishments that we have this system established. In your work area, what are some of the hazards? And we have to determine the critical control points. And we establish the standards for each critical control point, what the temperature should be, for example. We monitor the temperature, the critical points, okay? And then if the temperature is not right, we take the corrective action, and then we document, we verify. So that's what it stands for, okay? Hazards, H. A, critical control point, CCP, that's what it is. So every work area that has to do with food production, food service, we have to have this documented. Okay? One thing we have to remember is that you have to remember the danger zone. This is the danger zone that all bacteria loves to stay in, 40 to 140 degrees Fahrenheit. So the danger zone is 40, easy, I'm bound to test you on this, 40 to 140 degrees. That's the danger zone. So don't leave hazardous food at room temperature. Everything should be either in the refrigerator or in what? The steam table. This is why when they serve food for a whole hour, they could do that. But they have to constantly take the temperature to make sure the temperature of the food is above 100, it's at 165. That's the temperature to assure safety. Okay, so the danger zone you need to know. So that's why the thermometer is so important. Okay, inhibitors. Okay. There's several chemicals that could inhibit germs or bacteria. Antiseptic only inhibits growth. It doesn't work. Antiseptic spray, you spray everywhere, it doesn't kill the bacteria. Disinfectant only kills the vegetative forms. It does not kill the spores. Okay. The only thing, the only inhibitor that actually assures of sanitation is a sanitizing agent. When you work in the visitor room, you see the 3 compartments: washing, pots and pans, rinsing, and the last step is sanitizing. Chemical, you have to follow instruction how much chemical to use, sanitizing agent to rinse. Then it reduces to that level, which is a safety level, basically kill all germs. Okay, so sanitizing agents sometimes in the incubator and all that, but sanitizing agent is just about the only thing that kills all. The 3 compartment sink I already talked about, or dishwashing. If you go to the visitor room, do dishes, you see the dishwashing machine. You always have to check it. The chef has to check it. Okay, the rinse machine must register 180 for rinse temperature to kill all. That's why when you go to the restaurant, the inspectors check what kind of dishwashing machine do you have. If it's a high temp, we have a high temp in the visitor room. This is the temperature you must reach, okay, to kill all germs. Okay, I'm almost done. Okay, temperature danger zone. Human body, of course, is 98.6. Bacteria love it. If you have to leave, go ahead and leave. But I need to finish up. Danger zone, you must know, 40 to 140. The cold food, all cold food must be stored below 40 degrees. Hot food must be above. Okay, so the danger zone is between 40 and 140, either in the steam table, which registers 160, or refrigeration temperature below 40. Okay, so we heat food, beef and all meat, everything to above 140. Holding temperature, which is the steam table, steam tables must register 165. You need to know 165 degrees. Okay, and 40 to 140 boundary lines you must know. Okay, temperature critical control. Cooling and heating. Food must be cooled to 40 degrees in 4 hours. You need to know that. In 4 hours after you cook, it needs to be cooled to 40 degrees. So the only way to do it is to put liquids in shallow pans, less than 3-inch deep, so to cool it faster. Okay, if anything that's thick foods, okay, you have to put it in even 2-inch deep pans to cool it faster. Okay. And storage temperature, refrigeration, we already know that. Freezer temperature has to be below 0 degree Fahrenheit. Okay. But if it's a sub-zero, it's even better if you have that. Okay. Freezer. That's why the lower is the temperature, the better is the texture, the better it is for you to preserve food. Okay. Storage time, 3 days maximum for fresh food. First in and first out, anything. When you store it, whatever you stored there 3 days ago, 2 days ago, a day ago, you take out first in. The item that you stored 3 days ago should be used first. The item that's only stored a day ago could wait. That means first in, first out. That's how they stock food. They stock from the back. So that whatever that was stocked first, you use it first. Okay? Don't let them store for too long. It's what it is. First in, first out. It's a practice we should use